Okay, we should be on page 498, and we're on lesson 8-3. Example 1 says, Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, and then list the data in order from least to greatest. What can Finn notice about the time spent on homework? So I want to look at Finn's data, and we know that this line is the median, and his median is 5. We know that this line is the maximum, which is at 11, and this line is the minimum, which is at 1. And then we also know our quartile 1 is at 3.5, and our quartile 2 is at 6.5. If we look at Jonah's data set, Jonah's median is 7. The maximum is 11, the minimum is 1. But the quartile range, or quartile 1 is at 5.5, and quartile 2 is at 8. So looking at this, the question is what can Finn notice about the time spent on homework? Finn can make an inference that because the median is 7 in Jonah's set and the median is 5 hours in Finn's set, we can infer that more people studied for longer in Jonah's middle school. I'm going to put MS for middle school. We also can see that our minimums are the same and our maximums are the same. So the only really data points we can look at are my quartile ranges and my median there. Now let's do the try it. Okay, it says, Kano gathers the heights of a random sample of 6th graders and 7th graders and displays the data in box plots. What can you say about the two data sets? So first of all, we're talking about the median. So I need to go over here and I need to mark my median. So my median for 6th grade looks to be 62, and my median for 7th grade looks to be 63. So I can say the median of the blank grade sample is greater, so the 7th grade sample is greater than the median of the 6th grade sample. Now, the second part is asking about variability. Remember, variability is compared to how large your interquartile range is. I'm going to write down here your IQR is always Q3 minus Q1. So for my interquartile range here, I would have 64 and 58. So I would do 64 minus 58, and I get 6. And then here, I have 68 and 58. So I would do 68 minus 58, and I get 10. Whichever one has the largest IQR gives us the largest variability. So larger IQR equals larger variability. So if I look here, the larger IQR is for my 7th grade sample. Now let's look at example 2. It says, Finn and Jonah analyzed the measures of center and variability of the data they collected. Do these measures support Finn's assessment of the two data sets in example 1? So we're comparing it back to our example 1. And if we look, we still have all the same data points. So Finn's data, first quartile is 3.5, third quartile is 6.5, first quartile for Jonah's data is 5.5, third quartile is 8. We are going to look at the medians and the interquartile ranges here. So we can see that Jonah has a higher median, but Finn has a higher interquartile range. So if we look, we can say, just like we said in example 1, we can use the same data, but now we're talking about the interquartile range of them. We can say that Finn's data shows less people study than Jonah's data. We also, looking at our interquartile range, we can see that Finn's data had a larger variability. Finn's data had larger variability. If we look at example 3, it says, Mr. Bunsen had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plots show the height of all the plants after 3 weeks. How did the 2 populations compare? What inferences can be drawn? So first of all, I just want to list all of the things I can read on my box and whisker. So my medians are both 12 in this case. 12 and 12. My maximum for room 7D is 18. My minimum is 5. My quartile 1 is 8, and my quartile 2 is 14. Remember that from 5 to 8 is my quartile 1. This is my 25%. From 8 to 12 is quartile 2. That's another 25%. From 12 to 14 is another 25%. That's quartile 3. And the last but not least, 14 to 18 is quartile 4, another 25% there. So let's look at 7G. My minimum is 6. My maximum is 20. My quartile 1 is 10. My quartile 3 is 16. So why don't I find my IQRs? For this one, my IQR would be Q3, which is 14, minus Q1, which is 8, which gives me 6. And then for this one, my IQR is 16 minus 10, which gives me 6 as well. So I can see that my IQRs, I'm going to write it here, IQRs equal same. What about my medians? I can look and I can say my medians equal the same. They are both at 12. So the things I want to compare are my maximum and my minimums, because those are the only other points that are not the same. So I can see that room 7G has a larger minimum and a larger maximum than room 7D. So I can finally infer that the plants in 7G grow faster. Okay, now I want you to do your try it. It says, a local recreation center offers a drop-in exercise class in the morning and in the evening. The attendance data for each class over the first month is shown in the box plots at the right. What can you infer about the class attendance? So first of all, let's list my data. I have my median here is 4.5. My median here is 6.5. My IQRs here, I have 3 for quartile 1 and 6 for quartile 2, 5 for quartile 1 and 8 for quartile 2. My minimum in the morning is 2, my maximum is 8. My minimum is 3, my maximum is 12. Just looking at this, we can make an inference because my minimum and my maximum are enormously larger than my minimum and my maximum in the evening. So right off the bat, I can infer that the class attendance is better. Oops. in the evening due to their maximums and minimums. Okay, I do want you guys in your workbooks to answer questions 6, 7, and 8. You do not need to tear this out. We will go over it another time, but I want you to complete question 6, 7, and 8. I am fully aware I said 6, 7. You cannot laugh about that. Thank you. Have a great day, and I will see you all on Monday.